Hi, I'm going to talk about using a cumulative distribution plot, also known as an ECDF plot or an empirical cumulative distribution plot. And I'm going to show you the advantages of using this plot over others. So I'm just going to filter my data on, let's say, one particular day. And all these plots are Python plots, and they're used to describe distributions. So we have your ECDF plot, histogram, KDE plot, and your box plot. Now, all these will give us some degree of how to describe how our data is spread across or distributed. For example, if we just jump down here and we look at the histogram, we can see that the majority of these bins and then these tall bins are going to be where our data is kind of situated. If we choose another day, we'll get a little bit of a better look at that. So you can see that about the $3.50 range, we have the highest bin, which is for our tips data set. And the data set we're looking at, and let me just show it to you. We're looking at a tips data set where we're looking at the time, dinner or lunch, and the total bill amount, the tip. We have the sex of male or female smoker, and the day of the week, and then the size of the party. So if I go back to that, we can also kind of use a KDE plot that gives us a little bit of a different metric when it comes to looking at distribution. Histogram is going to deal with count, and the count is going to be in these bins. And then when we're looking at KDE, it's the density. So like something that you see with this is like when you look at a normal distribution, we know that we can look at the standard deviations and tell where, 65 or 95 or 99% of our data is just by looking at something that's normally distributed. But we can also see that the biggest density is also around that 3.5 range or $2 to $4 range. And a box plot also shows us a distribution. We know that this is $2 to $4, and this is going to contain most of our data. And this is our median. So we have our first and third quartile that we can look at to see where our data, 50% of our data would be, which would be under that $4, around that $4 range. So then when we get to the ECDF plot, we also have our way of using this. On the right side of the y-axis, you can see the word proportion. So the y-axis is actually going to represent our percentiles. So we can look at that $3.50 range, which would be here. And then we could just navigate up, and we can see maybe it's about at the 70th percentile. So that means 70% of our data, well, let me move over a little bit. Actually, if we wanted to look at our percentile, we could see at $3.50, if we go up, we're looking at about 50% of our data is at $3.50 and below. And then if we wanted to go all the way out to here, we can look at the $5 range that we can say at $5, we're looking at about 80% of our data is at $5 and below. So that's kind of how we use an ECDF plot. So let me show you the code, and I'll show you the code for each one of these. So let's just start with the histogram, because they're all very similar coding, so you can quickly pull up these different plots very easily. The first thing we're doing is importing Seaborn, saving it as SB. We're importing matplotlib.pyplot, saving it as PLT. We're using a background style called ggplot. And all I'm doing here is using that matplotlib variable to pass in different styles. For example, I'm adding a title for histogram, and then the tick sizes here, which represent the size of the X and Y axis, labels here. And then we're using that Seaborn variable to pass in the function that brings in that particular plot. For example, a hist plot, which represents a histogram plot, I'm passing the data in as our data set. And your data set is here. Anything you bring into the values is going to represent your data set, and they're going to drop the duplicates. Then I'm using X, which is the tips. And then I'm using something called a hue. The hue in Seaborn allows you to separate your data by category. So you can see that I have categories here, and we can look at day or smoker or time for those categories. But let's just go through the rest, and then I'll go and show you how we can change the hue in the ECDF plot. So for the KDE plot, it's almost identical. All we're doing is passing in kind of a new parameter called shade, just to get this shaded look. But the hue is the same, the X is the same, and the data is the same. It's just a data set variable here. If we go to box plot, and let me open that back up. Very similar. We're using data as data set. We're using the box plot function. X is the the day here, and Y is the tips. So in that one, we're not actually using the hue for that particular plot. So if I go to the ECDF plot, it's the same structure. It's just when we get to our Seaborn variable, we're passing in ECDF plot, and then we're using hue as day. Now I can change that hue to another category. We have smoker here, and I can pass that in. And then what you're going to do is see two different separate lines there. And you can see the difference between those two distributions, where we can see that the smokers have a little bit more when it comes to our particular line width. So we could see at $6, as non-smokers, we have 100% of their data is $6 and below. And at our smokers, we can see that at $6, it's not necessarily 100. It might be around the 90th percentile, so 90% and low. So it looks like smokers may be leaving a larger tip on a particular day. Now we can further style these plots. So you can see on these different ECDF plots, all I did was kind of make the lines bigger here, and I used a different color palette. And that's very easy. We just use those parameters in the particular plot function here. So you can see I passed in palette as summer and line width as 5. And I'm comparing Saturday and Sunday so we can see the two differences. And you can see that those lines are different here. So you can look at, the the $3 tip is at around the 45th percentile for Sunday, while if we go up to Thursday, we can see that $3 range is at the 70th percentile. So it looks like, we can tell that Sunday people might be leaving higher tips. Next, we can look at this same plot, but we can switch our X and Y axis. In a sense, if we look at these two, you can see that we have proportion here, but we have proportion here. I changed the palette also. So it might be easier for you to read the ECDF plot this way. For example, if we look at that $2 range, we can see that if we're looking at Sunday, this looks around the 20th percentile for $2. And then if I use Sunday here, which is in purple, and I looked at $2, and I can see that that flat line stops around there. So that's also at the 20th percentile. So you're just looking at these different. And at this plot, we're using a a different section where proportion is here, but we're flipping everything. So if this is 1 minus, so we would read this differently. And let me just show you the code here also. All we're doing is passing in the parameter complementary equals true. And that will allow us to say 80%. So we're not using percentiles at this point. If you're looking at this, if we look at the $2 range, instead of saying this is at the 20th percentile, which means that 20% of your data is below this, you can look at this one and say, well, 80% of your data is above that $2 range. So it's just kind of a different way of looking at it. And for this particular plot, we didn't look at the code, but let me just show you. All we're doing is choosing the Y for tips instead of the X for tips, as in this plot. And this one, if you look at this ECDF plot, we're not using proportion, we're using count. So this is really helpful when we have more than a few plots, because you can see it now kind of looks like a hand, and you can see on this particular day, there are not a lot of observations. So we can see that this day is not a very, popular day for people leaving tips. And we can see that this is the actual count of observations. So that's an ECDF plot. I'll just kind of go through the code very quickly. So you can easily bring this in by bringing in Seaborn, which is the main thing that's going to allow you to create that particular plot. We use matplotlib to use for styling. So that's matplotlib.pyplot, and we can always save that as a variable. I just use PLT. You can change it to anything you want. We can use that variable then to create different styles for our particular plot. And we can look at adding titles and font sizes. And then the main part of your code is going to be your ECDF plot function that we bring in with Seaborn. And you bring in your data set, you set the X or Y, depending on how you want to read that plot. And we can set our hue if needed. And then the last part of that code is just using the matplotlib variable to show your plots. So I hope that kind of gives you a different way to use, the different distribution plots here to describe your data. Thank you.
Hey everyone, thanks for tuning in to Enterprise DNA TV. If you enjoyed the content covered in this particular tutorial, please throw the video a like. It really helps us and we really appreciate it. Also, don't forget to subscribe to the Enterprise DNA TV channel. We have a huge amount of content coming out all the time from myself and a range of content creators, all dedicated to improving the way that you use Power BI and the Power Platform. Lastly, check out Enterprise DNA's website, plenty of resources and further learning that you can access very easily. All the best. Take care.